We will be talking about chemical bonds today, how atoms combine or join up with each other to create compounds. So here first we will see a helium atom which has 2 protons inside the nucleus and 2 electrons in its outer or the single orbit or shell. So the first orbit requires only 2 to get completely filled up. So this is called a duplet, and since its orbit is completely filled, it does not need any other electrons and it is fully satisfied. So it does not combine with any other atom, it does not react, and therefore it is called an inert gas, which is completely non-reactive and does not create bonds. Similarly, we can see the case of neon. So neon has 10 protons and 10 electrons, which means the first orbit has 2, the outer orbit has 8. So outer orbit also has only the capacity of 8, so it gets completely filled up. So in neon, since it is already full and satisfied, it does not create any bond with any other atom and it does not react and is an inert gas. So all other atoms which do not have their external orbit full want to go to the state in which inert gases are, which means they want to fill up their external orbit, outer orbit, which is also called the valence shell. So we will now see this, some other atoms and how they create bonds trying to imitate the inert gases. So to begin with, we see chlorine, which has in the outer orbit it has 7 electrons. So which means chlorine just needs 1 more to fill up the outer shell, its valence shell, and it is easy for us to borrow 1 more electron from another atom rather than giving away the 7. So chlorine is therefore a non-metal. Non-metallic elements are those who want to accept electrons, and since it's only the outer shell which is important, we show it with the help of a diagram where there is symbol of chlorine and only the outer electrons shown. This is called a Lewis diagram, and which helps us to understand bonding very easily. So here is a Lewis diagram of chlorine which wants to accept 1 more electron. And here we show the case of sodium, which has only a single electron in the outer shell. So the Lewis diagram is sodium symbol plus 1 dot. And now sodium wants to give away this single electron. It's very easy to give it, and therefore sodium is a metal, an element which behaves like a metal, which means it wants to give away its outer electron. So now we will see how sodium and chlorine will want to combine with each other or react with each other. One wants to give and one wants to accept. So they will make an easy bond with each other. So here is chlorine with 7 electrons in the outer orbit and sodium with a single one. So sodium wants to give, chlorine wants to accept. So sodium gives away its single electron to chlorine. We are showing the electrons with bindis on a smooth surface. So here sodium gives away its electron. So chlorine's need is satisfied, its outer shell becomes filled up by accepting 1 electron, and it becomes a negative ion because of having 1 extra negative charge. Sodium on the other hand also has its octet complete because the outer shell is gone. So now sodium will have 1 extra positive charge because it has given away 1 electron. So both of them become ions, and since they have charges on them, both of them will stick to each other, both ions will stick to each other to create a white solid, which is sodium chloride or common table salt. So this kind of bonding where borrowing and accepting of electrons is followed is called an ionic bond or electrovalent bond. So we will show some more electrovalent bond using calcium. Now calcium is also a metal, but it has 2 electrons in its valence shell, outer shell, and calcium would want to give both of them. So calcium now can give it to any non-metal. Here it is giving it to chlorine. So one electron goes to chlorine, chlorine's need is satisfied, and chlorine becomes a negative ion. So here calcium's need is still not complete. Calcium wants to give one more, but chlorine becomes a negative ion with a single negative charge. So calcium has to give one more. So calcium will combine with another chlorine. So calcium's valency is 2 if it can give 2. So it combines with 2, it gives its remaining electron to another chlorine, and therefore the next chlorine also becomes a negative ion. Calcium will become a positive ion with 2 plus charge, and chlorines will become 2 negative ions. So this is CaCl2. So one positive ion and 2 negative ions. Now let us look at the very interesting case of hydrogen, which has a single electron in its only shell. So hydrogen can give away this electron also. That it also does that to create electrovalent bonds. But there is another kind of bond which are made where hydrogen now, instead of giving it this outer electron, it actually shares it with another hydrogen or another atom. So here it is sharing with another hydrogen. So both of these atoms have overlapping outer shell, their outer shells overlap, and the single electron is shared between both. So now both hydrogens have their external orbit, the single first orbit, complete with 2 electrons, and their requirement is complete. So this is a molecule created by sharing, which is called a covalent bond, and this becomes a molecule H2. So hydrogen gas remains in the form of H2 by creating such molecules through covalent bonding. We will see another case here of oxygen. So oxygen has 6 outside, and to complete its octet, oxygen requires 8. So what it does is that it shares its outer electrons with another oxygen, and shares, instead of 2, it shares 4. So both oxygens contribute 2 each, and therefore 4 electrons are shared. So each oxygen has 4 by sharing and 4 others. So total 8 is complete, and we get a molecule called O2 through covalent bonding. And this is how oxygen gas normally stays in the atmosphere as O2 molecules. So covalent bonding is also very common, where electrovalent bonding is not possible, and these do not create ions because there is no extra charge. They don't create ions. Here now we will see how oxygen creates a very interesting molecule, very common, which is water. So here one oxygen shares its 2 external electrons with 2 hydrogens. So both hydrogens have their outer orbit overlapping with oxygen. Both of them contribute 1 electron each, and oxygen also contributes 2 electrons. So the need for hydrogen as well as oxygen is complete. Oxygen gets 8, hydrogen gets 2 each, and this is H2O, which is a very stable and strong molecule made by covalent bonding. Now in a classroom, if we want to do this exercise, we can use hands. So children can create 1 element each. So here is chlorine with 7 electrons, and there is 1 sodium, Na, with 1 electron, and sodium gives away its electrons, shown with bindis, and chlorine has its requirement complete, and sodium also has its requirement complete. So we have NaCl formed like this. This is a good classroom exercise which children can do. Similarly, children can also create covalent bonds. So here is chlorine and chlorine coming together and sharing one each. So two external electrons are shared between the two to create Cl2.